largest ever primate to walk the planet would have towered over the smallest human if they had ever met. Two evolutionary dead ends with valuable stories to tell. Gigantopithecus blacki, or Giganto, stood almost 3 meters tall, weighing 150 kilos, and was vegetarian. Homo floresiensis, or the Hobbit, was a mere 1 meter tall and hunted Komodo dragon. What do these fascinating creatures have in common, and what can they tell us about our own survival? They both lived in Asia, occupying forested or rainforested environments. Their timelines overlapped from around 1 million years up to about 300,000, and both overlapped with human occupation. Their evidence is found within caves, and both became extinct in the last 300,000 years. Causes are still unknown. They are both evolutionary dead ends. Their lineage has not continued, but their extinction has a bearing on our own survival and adaptation capabilities. But their stories are not yet complete. The Hobbit remains in Lianbua were recently dated to 60 to 50,000 years ago, implying that modern humans may have had a hand in their disappearance. But there is also paleoclimate record from stalagmites that implied a vegetation collapse shortly before their disappearance. Humans versus climate story is not clear. Giganto's last stand in southern China saw a huge range reduction and evolutionary changes, implying a stressed population. Their exact extinction is unknown, but thought to be related to habitat deterioration around 300,000 years ago. It would seem that it doesn't matter if you're big or small. If you don't adapt as a species, you are finished. Is this the key to our survival? Our ability to adapt and compete? These mysteries can be unravelled by the dating of a grain of sand. Luminescence dating is a technique that harnesses a light-sensitive signal to estimate the time since minerals, such as quartz and feldspar, were buried in the cave. The amount of light, or luminescence, is proportional to the time since burial, and hence the deposition age of the associated fossils. The value of luminescence is that it can be applied to all sedimentary environments. So we've been working really hard to try and develop techniques specifically for cave environments, which then makes it a really valuable tool for dating Giganto and Hobbit remains. We're using single grain methods because they can produce a much more precise age, and then we can really define this extinction window. And once we know the extinction window, then we've got a really good chance of then trying to identify the causes for extinction within a really constrained time period. Using multidisciplinary techniques, we've been able to reconstruct the climates and the environments of the Hobbit, how they lived, how they behaved, and the prevailing climatic conditions. This allows us to put skin on their bones and learn their stories. The same goes for Giganto. Detailed analysis of their teeth using a scanning electron microscope has really revealed their dietary preferences and allowed us to understand the level of environmental dependence. Now all we need to do is build up this evidence of how the environments have changed during this extinction window. Two diverse species at either end of the human tree, displaying striking similarities that can both help us to understand about modern human capabilities and adaptation. The value of their stories is unlocked by dating and the definition of their precise extinction windows. But there is much to learn about these fascinating evolutionary dead ends, and research into the long and the short of their extinction is ongoing.